time. We live by it, measure our lives with it, and race against it. Yet what if this all-powerful force we organize our entire existence around isn't even real? Could time be nothing more than a mental construct, an illusion crafted by our minds to make sense of motion, memory, and change? This question has intrigued scientists, philosophers, and mystics for centuries. And in recent years, with advances in physics, cosmology, and neuroscience, we're closer than ever to cracking the code. In this deep dive, we'll explore what time really is, why some believe it doesn't exist at all, and what it would mean for our reality if they were right. In our everyday lives, time feels linear. It ticks away second by second, moving from past to present to future. This is the Newtonian view, where time is an ever-present backdrop, flowing at a constant rate, independent of everything else. Isaac Newton believed that time and space existed independently of observers. Time in this model is an absolute framework, like a stage on which the universe plays out its events. This view dominated scientific thought for centuries. However, even Newton acknowledged he couldn't define time clearly. He called it absolute, true, and mathematical time, something that exists regardless of whether we perceive it. Einstein radically altered our understanding of time. According to his theory of special relativity, time is not constant, it's flexible and relative. The faster you move through space, the slower time moves for you. This phenomenon is called time dilation. Here's the mind-bending part. Two observers moving at different speeds will experience different amounts of time. This was proven by synchronizing atomic clocks, one on Earth and one on a fast-moving plane. The clock on the plane ticked slower. Einstein's general relativity took it even further. It showed that gravity isn't just a force, but the curvature of space-time. Massive objects warp the fabric of space-time, and time itself flows more slowly in stronger gravitational fields. That means time runs slower near a black hole than it does in open space. These theories fundamentally shattered the notion of universal time. There is no single absolute now that everyone shares. Time depends on where you are and how fast you're moving. Take a deep breath. In the block universe theory, also called eternalism, the past, present, and future all exist simultaneously. Time doesn't flow. That's just an illusion of consciousness. Imagine time as a loaf of bread, with each slice representing a moment. All the slices exist. You're just experiencing them one at a time. This theory suggests that all events are fixed within the block. Your birth, your future, the end of the universe, all of it exists eternally. While this idea feels strange, it's mathematically consistent with relativity, and it raises deep questions. If the future already exists, do we really have free will? Or are we just playing out a predetermined script? Quantum mechanics, the theory that governs particles on the smallest scales, treats time in a weirdly one-sided way. The Schrödinger equation, which describes how quantum systems evolve, uses time as a fixed parameter. But in general relativity, time is a dynamic part of space-time. This creates a fundamental mismatch when trying to combine the two theories. Some versions of quantum gravity, such as the Wheeler-DeWitt equation, don't include time at all. It disappears from the fundamental equations of the universe. This leads to a terrifying conclusion. Maybe time isn't fundamental, it might be emergent, a byproduct of other, deeper laws. Could time be like temperature? Not something that exists on its own, but something that emerges when many particles interact. One of the few things that makes time feel directional is entropy, the tendency of systems to move from order to disorder. According to the second law of thermodynamics, entropy always increases in a closed system. This gives rise to the arrow of time. Why eggs don't unbreak, why ice melts but doesn't unmelt, and why we remember the past but not the future. If you played a video in reverse, you'd notice. Because entropy would be decreasing. But physics equations don't care about direction. Most fundamental laws work the same forwards and backwards. So why does entropy always increase? Some physicists argue that the arrow of time is just a statistical illusion. Others suggest that the universe started in an extremely low entropy state, the Big Bang, and it's been increasing ever since. Still, if entropy gives time its direction, it's not enough to say time flows. It's more accurate to say entropy grows. Now things get personal. Neuroscience suggests that time may not be something we perceive. It may be something we construct. Your brain doesn't have a built-in clock that ticks in real time. Instead, it stitches together experiences using memory, attention, and prediction. This constructed experience of now is known as the specious present, a short window of time your brain treats as the present. Time feels slow when you're scared, fast when you're distracted, and warped during altered states, like dreaming or using certain drugs. That's because your perception of time is deeply tied to emotion, focus, and internal processing. Some neuroscientists argue that time is simply a cognitive tool, something your brain uses to navigate change and causality. What if time isn't a physical phenomenon, but a virtual one? The simulation hypothesis, popularized by philosopher Nick Bostrom, suggests that our reality could be a computer simulation. If that's the case, then time is just part of the simulation code, rendered frame by frame like a video game. This would explain why quantum events appear probabilistic, like outcomes are generated on demand, and why information behaves strangely near black holes. Time might not be continuous at all, but quantized, like pixels on a screen. In this view, time is a computational process. When the system doesn't need to render a change, nothing happens. This is why some scientists believe the universe might only calculate outcomes when observed. Philosophy offers its own takes on time. Presentism. Only the present moment is real. The past no longer exists and the future hasn't happened. Eternalism. All moments, past, present, future, are equally real. Time doesn't pass, it just is. Growing block theory. The past and present exist, but the future is constantly being added, like pages to a growing book. Each view reshapes how we think about memory, choice, and fate. If eternalism is true, then our sense of becoming is an illusion. If presentism is true, then time is being constantly recreated every instant. Time travel is a staple of science fiction, but it's also a serious topic in physics. Einstein's equations allow for closed time-like curves, loops in space-time that could permit time travel. Theoretical objects like wormholes might let someone jump between points in time. But then we get paradoxes. What if you go back in time and prevent your own birth? The grandfather paradox. Some physicists think these paradoxes might be resolved with alternate timelines or self-consistency principles, like the Novikov self-consistency principle. While backward time travel remains speculative, forward time travel is real. Astronauts aboard the International Space Station age slightly slower than us due to time dilation. It's tiny, but it proves that time travel into the future is possible. If time is a construct, physical or mental, then is it possible to exist outside of it? Mystical experiences, deep meditation, and near-death experiences often involve a sensation of timelessness. Some believe that consciousness itself may not be bound by time. Others suggest that if time is emergent, then whatever lies beneath it, the source code of the universe, might be timeless. Some interpretations of quantum mechanics even allow for a reality where change occurs without time. Perhaps in death, dreams, or deep states of consciousness, we glimpse something beyond linear time. Time is possibly the most familiar yet most mysterious concept we know. It governs every heartbeat, every sunrise, every memory. But whether it's an illusion, a construct, or a multi-dimensional slice of space-time, one thing is certain: time demands to be questioned. So, what do you think? Is time real? Can we exist outside of it? Or are we just brains swimming in an endless illusion? Drop your thoughts in the comments. Let's unravel time together. 3-3. You made it all the way here. Brain spinning, questioning if time is even real. And you're still not subscribed? Look, this channel isn't just content. It's a mental roller coaster through black holes, brain glitches, and bizarre theories your school never dared to teach. If you're into stuff that blows your mind and makes you say, wait, Lasti, what did I just watch? Then yeah, you belong here. Smash that subscribe button so we can decode the universe together. Or at least get really confused trying. And hit the bell too, because if time is fake, notifications better be real. Let's get lost in the weirdest questions of existence. One rabbit hole at a time.